Now that we know how to find the least common denominator of rational expressions, we can start to add them. So first we have to find the LCD, and in this example here on the left, we actually already found the least common denominator of the 16x squared y cubed and 56xy the fourth. We found that the LCD was 112 x squared y to the fourth. Now we have to make both denominators look like that. So first step, find the LCD. Second step, make the denominators look like the least common denominator. So what times 16 would give me 112? Well, if we divided, we'd figure out it was 7. Or we could actually look up here and see we had the 4 2's, we didn't have the 7. So we're going to have to multiply by 7. And actually I want a little bit more room here. So we're going to multiply by a 7. Whatever we do in the denominator, we have to do the same thing in the numerator. So then we would have 112. We already have the x squared. We need y to the fourth also. So we have y cubed. That means we need one more y. So now this rational expression on the left would become 77y, right? 7y times 11 over that LCD of 112 x squared y to the fourth. Now this rational expression here on the right, I have 56. And the question is, how do I make 56 into 112? I have to multiply it by 2. Again, whatever I do in the denominator, I do the same thing to the numerator to keep it equivalent. And I need x squared, and I only have one x. So I have to multiply by an x as well. And then I already have the y to the fourth, so that's set. So 17 times 2x would be 34x over 112 x squared y to the fourth. Once they have a common denominator, then I can add them. So 77y plus 34x all over 112 x squared y to the fourth. Remember, we add the numerators. They're not like terms, but we can combine it into one fraction or one expression. The denominator stays the same. The last step is always to factor and see if anything divides out. So I know that 77 is 7 times 11, and 34 is 17 times 2, and those have nothing in common, so it doesn't look like there's anything I can factor out, so that is as far as we can go. Alright, let's look at another one here. So we've got x squared minus 16 and x minus 4 in the denominators. First step, find the LCD. X squared minus 16 is a difference of squares. I can factor that into x plus 4, x minus 4. And then this one is already factored as far as it will go. So the LCD will be, they both have an x minus 4. So I need that, and I need an x plus 4 to make the one on the left. Alright, so once I have my LCD, I need to make my denominators look like that. This one here on the left already has it. It has x plus 4, x minus 4. I do not need to multiply by anything. This is going to stay the same. The one on the right has the x minus 4, but it doesn't have the x plus 4. So I need to multiply the numerator and denominator by x plus 4. Remember, the goal is to make the denominators look the same. So now they both have an x plus 4, x minus 4, x plus 4, x minus 4. And then I'm going to go ahead and distribute that 4 times the x plus 4. So the rational expression on the left will stay the same. X plus 4, x minus 4. I'm going to go ahead and leave the denominator in factored form, since after I add the numerators, I'm going to have to see if anything factors out. So minus, now I have 4x plus 16 when I distribute. All right, so I've distributed the 4, but now I have to think about this subtraction here. I have to subtract all of it. So it's going to go to the 4x and the 16. So in the numerator, I'll have 8x minus 4x minus 16 all over the LCD. So the denominator doesn't change. And then I combine my like terms. 8x minus 4x is 4x. Still have minus 16 all over. The LCD does not change. After I've added the numerators and kept the same denominator, I factor again to see if anything else divides out. In the numerator, I can take out a GCF of 4. That leaves me with x minus 4 over the same denominator. So that's, again, why I left this in factored form, because eventually I just have to factor it. I see the x minus 4's divide out, and that leaves me with 4 over x plus 4. Those 4's do not divide out because it is not a common factor down here. If I can't take it out of the x, it's not a factor. I have to be able to pull it out of everything, which I can't. So do not try to divide those out. This is as far as we can go. All right, let's look at one more here on the left. Looking at these, m minus 6 and 6 minus m, those are actually very similar. If I tried to rewrite this 6 minus m in standard form, it'd be negative m plus 6. Now what I could do here is I could factor out a negative 1, and that would leave me with m minus 6. So because this is a rational expression like a fraction, when I take that negative 1 out, I could rewrite this as 8 over m minus 6. That whole thing is negative. Oops, I guess I don't really want the parentheses there. Right? A fraction, if I put the negative in the numerator, if I put it in the denominator, if I put it out front, those are all equivalent. So all I'm doing is I'm taking this negative 1 and I'm pulling it out front. So now this means I have 20m minus 20 over m minus 6 minus, from this subtraction here, and then I have this negative out front of my rational expression. And what happens when I subtract a negative number? When I subtract a negative, it becomes plus, right? Those two negatives multiply together to make a positive. So this one I actually didn't have to find the LCD. I just had to pull a negative out. And now I have 2m minus 20 plus 8 all over m minus 6, since the denominators match. I combine my like terms. I have negative 20 plus 8 would be a negative 12. Once I've combined my like terms, I factor one last time. In the numerator, I have a GCF of 2. I pull that out, and I see m minus 6 divides out from the numerator and denominator, leaving me with only 2, or 2 over 1. Go ahead and try the examples on the right, including this last one with addition and subtraction. Okay, Let's try to add these two here on the right. 7 divided by a cubed times b plus 9 divided by 2a to the 4th b. First step, we have to find the LCD. Remember, we're taking the most of each factor that we see. As far as the numbers go, there's only a 2, so I have to take that 2. Then I look at a cubed and a to the 4th. Which one has the most? I take a to the 4th. They each have 1b, so I take 1b. There's the LCD. Now I need to make each term look like that, each denominator. The one here on the left has a cubed b. What is it missing? It's missing a 2, and it's missing an a. So I have to multiply by 2a, numerator and denominator. Now it's going to be 2a to the 4th times b. So 2a times 7 is 14a over 2a to the 4th b plus the denominator here is already 2a to the 4th. So I don't need to change this at all. If it makes you feel more comfortable, you could multiply by 1. But I still have 9 over 2a to the 4th b. I combine them into a single fraction. 14a plus 9 is still 14a plus 9, since they are not like terms, over 2a to the 4th b. That is a 4. I look to see if there's anything I can factor out. The top here, numerator, does not have a GCF, and it's 2 terms, not perfect squares. Looks like this is as far as I can go. Next example, they're trinomials. I have to factor each trinomial. I want 2 factors that will multiply to -12 and add to 1. 3 and 4 are 1 away from each other. If I want to multiply to a negative, one of them has to be negative. I'm going to put the negative with the 3 since I wanted to add to positive 1. So x minus 3 and x plus 4. The expression on the right, I need factors that will multiply to 8 and add to 6. Those are 4 and 2. 2 times 4 is 8. 4 plus 2 is 6. So I have x plus 4 and x plus 2. So the LCD, they both have an x plus 4, but I also need an x minus 3 and an x plus 2. Alright, now that I have the LCD, I need to make sure that both the denominators look like that LCD. So this expression on the left has the x minus 3 and x plus 4. What it doesn't have is x plus 2. So I have to multiply numerator and denominator by x plus 2. The expression on the right has the x plus 4 and x plus 2. What it doesn't have is the x minus 3. So these are binomials being multiplied. I have to FOIL or box it out, choosing whichever method you would like. I'm going to bring this down here. So x plus 1 times x plus 2 would be x squared plus 3x plus 2. Right? X times x gives me x squared. 1x plus 2x would be the 3x, and 1 times 2 would be 2. All over our LCD. X plus 4, x minus 3, x plus 2. Remember, you do not have to multiply that back together, because at the end, we're going to have to factor anyway. It's the numerator you have to multiply, because we have to add the numerators together. Alright, that'll be plus. I need to FOIL or box these out now. 2x minus 1 times x minus 3 is going to be 2x squared, and then a negative 1x minus 6x would be negative 7x, and negative 1 times negative 3 would be positive 3, all over our LCD. Now that I have them multiplied out, I can combine my like terms into one fraction. X squared plus 2x squared is going to be 3x squared. 3x minus 7x will be negative 4x. And 2 plus 3 would be a positive 5. All over our LCD. Alright, once I have combined it into a single fraction, I need to check to see if I can factor again. So my front or leading coefficient is not a 1, so I take a times c, or 3 times 5. I'm looking for factors that will multiply to 15 and add to negative 4. The only factors of 15 are 1 and 15 or 3 and 5. I cannot get negative 4 out of any of those, so our numerator is prime, can't be factored, and this is as far as we can go. Alright. Let's look at the next example. Factoring the denominators first. X squared minus 9 is a difference of squares. It goes into x plus 3, x minus 3, right? Difference of squares factors into conjugates. The expression on the right, we're looking for factors that multiply to 3 and add to negative 4. The only factors of 3 are 1 and 3. If they're both negative, they will add to negative 4 and multiply to a positive 3. So x minus 1, x minus 3. We need to identify the least common denominator. They both have an x minus 3, so I need that. And then I also need an x plus 3 and an x minus 1. Now I need to make both of my expressions have this denominator. The expression on the left has x plus 3 and an x minus 3. It does not have x minus 1. So I need to add in x minus 1 to the numerator and the denominator. The expression on the right has x minus 1 and x minus 3. It doesn't have x plus 3. So I need to multiply that to the expression on the right, both the numerator and the denominator. I'm going to go ahead and distribute those into the parentheses. So bringing this down here, I will have 2x squared, right? 2x times x minus 2x, which would be the 2x times negative 1, all over that LCD. Then, still subtraction, distributing a 3, it's 3x plus 9 all over our LCD. Sometimes I get the question, does it matter the order that you write these in? And the answer is no. This is multiplication, right? Multiplying, multiplying, and multiplication is a commutative. So as long as I have each factor, then they're equivalent, no matter the order you write them in. Alright, we are subtracting. We have to be careful with that subtraction. I need to subtract my entire quantity. So it's like distributing a negative 1 to everything in the numerator. So I'll have the 2x squared minus 2x, now minus 3x, and minus 9, all in the numerator. The denominator stays the same. Remember, denominators represent the size, and the size is not changing. We go ahead and combine our like terms. So negative 2x minus 3x would be minus 5x, all over our LCD. We check to see if we can factor. So I would need factors that multiply. Our leading coefficient is not a 1, so I would take a times c. 2 times a negative 9 would be negative 18. And I would need them to add to negative 5. So let's see, the factors of 18 are 1 and 18. Can't get 5 out of that. 2 times 9, cannot get 5 out of that. And 3 times 6, can't get 5 out of that. Those are the only factors, so I cannot factor this any further. This is as far as we can go. Alright, one last one here with addition and subtraction. So since this is all adding and subtracting, they all have to have a common denominator. This first one is factored as far as it can go. The last expression is factored as far as it can go. The only one we need to look at here is in the middle. I see a GCF of x, which we can take out, and be left with x minus 5. The LCD, as we can see, this has an x minus 5, an x and an x minus 5, and an x. So all of them can be condensed into x times x minus 5. They all have one or both of those. So the first expression there has the x minus 5. So that's in the denominator. What it's missing is the x. So I have to multiply x to the numerator and denominator. So now it looks like the LCD, x minus 5. The middle expression already has x and x minus 5. It's done. The expression on the right here has the x. It's missing x minus 5. Again, to the numerator and denominator. Now all the denominators look the same. So let's look at what's left in the numerator. We have 6 times x over x times x minus 5. The middle expression didn't change. And the last one, I'm going to go ahead and distribute that 2. So 2 times x is 2x. 2 times a negative 5 is negative 10. All over the same denominator. Alright, now that they all have the same denominator, we can add or subtract them. Notice here with this negative, or the subtraction, we have to subtract the entire quantity. So in the numerator, I'll have 6x plus x minus 35, and then distribute, right? So negative 2x, and then a negative times a negative will make a positive 10, all over the LCD. I combine my like terms. 6x plus x is 7x. Minus 2x would be 5x. So 7 minus 2 is 5x. And then a negative 35 plus 10 would be negative 25. All over our LCD. Last step, once I've simplified that, I have to factor it one last time. The numerator has a GCF of 5. So x minus 5 is left when you factor that out. And we have x over x minus 5 still, or x times x minus 5. And the numerator and denominator have a common factor of x minus 5. We divide that out and are left with 5 divided by x. So this whole expression up here simplified down to 5 over x, or 5 divided by x. In general, our steps to adding and subtracting rational expressions: 1. Factor all the denominators. 2. Find the LCD. 3. Get all the expressions to have that common denominator, multiply by what is missing to both the numerator and the denominator. Once all the LCDs are the same, you add the like terms in the numerator. Once it's simplified down as far as it's going to go, you factor one last time, divide out any common factors, and simplify the result.